Alright, so just going to go through a whole bunch of stuff to do with the unit circle here. This is from 10C if you're doing the Year 11 maths book. If you're in my Year 10 class, doesn't really matter where the questions come from. See if you can follow the working and make sense of it as we go along, because it's all the same work. Here we go. So for each angle illustrated, write down the actual coordinates of A, B and C in terms of sine or cosine. Well, here all we need to know, the y coordinates are of course the sine of the angle, and the x coordinates, they are the cosine of the angle. So when I'm talking about point A here, capital A, the coordinates, the x coordinate is the cosine value. So if I mark that coordinate there, yes, it has an actual value I could get on my calculator, but in terms of the sine and cosine, that would just be the cosine of 26 degrees would be the x coordinate, and the sine of 26 degrees would be the y coordinate. Not so bad so far. When we get to B, remember there's a couple of ways we could do this. The first step would just be, look, the x coordinate is the cosine of the angle. The angle is 146 degrees, so cosine of 146. And the sine of 146 degrees. The next step that we got to, remember, is that we always like to do it in terms of a reference angle. Now 146 leaves a little bit of an angle here away from the x-axis. How big is that? Hopefully you figured out that that was 34 degrees. So I could just as easily have written these values as, well, let's start with sine first because that's easy. Yes, it's 34 degrees away, but if I had 34 degrees on the other side, it would still give me the same thing. So sine of 146 is exactly the same as sine 34 degrees. The cosine of that point there, cosine of 146 degrees, is exactly the same distance as the cosine of 34 degrees. Remember, that's my 34 degree angle there, but it's in the negative direction. So I could just as easily call that negative cosine 34 degrees. And remember, the 34 is the reference angle, just how far away you are from the x-axis. They're all the same. Nothing else really changes with any of these. If I have a look at questions, part B, angle C, the coordinates of that point would be cosine of negative 35 degrees and the sine of negative 35 degrees. Nothing really special about that. And I've just lost power right in the middle of that question. That's a bit disappointing. Oh, it's coming back on. Hopefully it's got enough power there. I might need to pause and plug it in a second. Negative 35 degrees. You get the idea. Of course, if I wanted to do that in terms of a reference angle, yes, and that has. I'm going to pause and be back in a second. Well, it was a little bit more than a second, but it'll only seem like a second for you guys. So, here, yes, we had sine 35 degrees. Remember, if I wanted to do them in terms of the reference angle, because that was negative 35, it's the same triangle that I'd have if I went 35 degrees. The cosine would be the same. Cosine of negative 35 and cosine of 35 degrees are in fact the same thing. The sine of 35, well, the sine of negative 35 was down here. The sine of 35, which is the y coordinate there, it's the same distance, but negative 35 is the negative of sine 35, so you just write it as negative sine 35 degrees. That's just a bit of review of that sort of thing. Let's move on and see what else we got in this one. Oh, with the aid of a unit circle, your best friend in maths, complete the following table. Well, we better put a unit circle in here. Now, this is going to be a pretty rough sketch, but that's all you need. Because the unit circle is your best friend. Make sure you label the sine axis, the cosine of theta axis, so you know where you're getting your points from. It's a unit circle, so I better say that the intercepts are all at 1 or negative 1. There's my origin. Need to find sine, cosine, and tangent. Tangent we can put down there, but it's a bit hard to actually read it off that, so we're going to use it using sine and cosine anyway. And remember, your best friend introduced you to their little buddies. 60 degrees, 30 degrees, 1, 2, root 3, and 1, 1, root 2, isn't it? With 45 degrees there. Now, see, I would never actually ask you to memorize this table because you should have your best friend in maths. You should be really familiar with that. And your best friend's little buddies, because they're your best friend's friends. Of course you're going to know them. All right. Ooh, degrees to radians. Now for my year 10s, this might be new, but it's pretty easy. We want to use real measurements. Rather than calling that 180 degrees, we call that pi radians. This was 0 radians. Halfway to pi must be pi over 2, half of pi radians. If pi is 180 degrees, 360 must be 2 pi, which means when I'm down here at 270, I'm 1.5 times pi, which is, of course, 3 pi over 2. Let's see if this is going to help us. So let's do these conversions first of all. So 0 degrees is 0 radians, 90 degrees pi over 2, 180 is just pi, 270 is 3 pi over 2, 360 is 2 pi. Now I've gone another 90 degrees past, that's another pi over 2. So 2 pi plus another half, 2.5. How would I write that? 5 over 2, wouldn't I? That's 2.5, it's a fraction. So it's 5 pi over 2. All right, sine and cosine. So these are all the ones on the axes. I don't even need my best friend's little buddies. I got all excited, but we don't even need them. What's the sine of 0? What's the y coordinate when I'm at that point? Well, I'm not above or below, so the y coordinate would be 0. What's the x coordinate at that point? It's 1, isn't it? I'm 1 unit to the right of the origin, so the x coordinate is 1. And now the tangent. Remember, the tan of an angle is how far up on the tangent axis the point would reach. And, well, that's at 0 on the tangent axis, isn't it? So it's 0. There we go. The other way to remember it is that you can also, because for any point we've got this y coordinate being the sine of theta, and this x distance, the x coordinate being the cosine of theta, sine theta divided by cosine theta is exactly the same as, remember, that whole length there would be tan theta over 1. So tan theta is sine theta divided by cosine theta. That's the other way you can work out what the tangent of theta will be. Now at 90 degrees, I'm at the top here. Clearly my y coordinate is 1, so the sine of theta is 1. The cosine, I'm neither left nor right, so the cosine is 0. And the tangent, well, you can see if the radius is going straight up, it's never going to hit this tangent. Or if we use this rule here, 1 divided by 0, undefined, isn't it? And you get the idea. As I go around to pi, I'm going to have an x coordinate of -1, a y coordinate of 0, undefined, that's funny, and a tangent of 0, because remember, to get back to the tangent axis, I have to go through the origin all the way back until I hit that axis. That's what you get. At 3 pi on 2, I'm down the bottom here, so my y coordinate is -1. I'm neither left nor right, so my x coordinate is 0. And again, we have an undefined value for the tan of 3 pi on 2, or 270. 360 degrees, we're back to the start, 0, 1, 0, and I think you have the idea. Question 4. Use a unit circle to show that the sine of pi plus theta is equal to negative sine theta. Now usually when we do this, we like to show the angle in the first quadrant. It wouldn't actually matter, but if I add pi, remember pi radians is half a circle, or 180 degrees, so this would be at the angle pi plus theta radians. Now the sine value is the y coordinate. So here, if I'd drawn it perfectly to scale, that would have the value sine theta. It's the y coordinate, how high it is above. Remember that triangle is now spun around when I've added pi radians to it, so I've rotated it around pi. It's the same size though, isn't it? But it's in the negative direction. So when I add pi, I end up in a negative quadrant. Instead, if it was positive, I end up negative. So show the following. Show that sine of pi plus theta equals negative sine theta. Well, they're the same length, so this is negative whatever the value of sine theta is. If it was 0.6, this would be negative 0.6. If it was 0.4, it would be negative 0.4. That's all I want you to show. Nothing too bad. Without using your calculator, find. Let's get our best friend in maths out again. Told you it'd come in handy. Sine theta, cosine theta. All right, I've got my unit circle here. Sine of 137 is sine of 43. Well, there's 43. 137, you're not going to be surprised to find, it's going to be 43 back from 180, isn't it? So it's the same distance from the x-axis. Now the sine is the y-coordinate, so you can see that's why I've drawn the dots across to show they're going to have the same y-coordinate. Therefore, sine 137 would also equal approximately 0.6820. What about the next one? Let's get another unit circle happening here. So let's do C. Cosine of 143, if cosine of 37. Oh, that was so far out, I'm actually going to do it again. Wasn't much better, but I'll take it. There's 37 degrees, obviously not drawn to scale. 143, when I go around there, is also 37 degrees away. Now, what do I know about the cosine? Well, they'll have the same length, but the cosine of 143 is negative. So if cosine of 37 is 0.7986, the cosine of 143, it's the same size, but it's in the negative direction, isn't it? It's to the left of the origin. Negative 0.7986. Lastly, let's see if I can do a better one for E. Oh, that's a fair bit better, isn't it? All right, here we've got, I'm going to use a different colour just for some contrast, a lot of black there. Sine of 115, so I've gone to 90 and I've gone a little bit past. Sine of 115, and I'm told the sine of 65 is 0.9063. Well, there's 65 degrees, and sine of 115 just happens to be 65 degrees away from the nearest x-axis. So they are the same height. They have the same y-coordinate. Therefore, the sine of 115 will have the same value, 0.9063. All you really have to do, if they're the same distance from the x-axis, whether it's sine or cosine, just check the signs. Are they positive or negative? How do we do that? Remember, all students take crack. Not true, of course. They don't do that. But that's a good way to remember it. The sillier it is, the easier it is to remember sometimes. All right, find possible exact values for cosine theta if sine theta equals a half. These are fun because you're tempted just to say, oh, okay, well, let's just use, we could use sine squared theta plus cosine squared theta equals 1. Remember, that's our Pythagorean identity. The horizontal distance squared, the x squared, which is cosine theta squared, plus sine squared theta, Pythagorean identity has to equal the hypotenuse, which in a unit circle is 1, so that would be true. You can solve them using this, but my preferred method, if I'm given the sine theta is a half, just draw a right angle triangle, put in a theta, and then say, well, sine is opposite divided by hypotenuse. Now, with just a little bit of Pythagoras, you're going to get that side being root 3. And in fact, this is one of your best friend's little buddies that we looked at before, so it's not so bad, is it? All right, now, if sine theta is 1/2, where are the possible positions? Well, there's 1/2. Well, there was 1/2 till it decided I was so long on one point that I must have been wanting to right-click. And you can see there are two possible angles that would give me the sine of theta equaling 1/2. Now, cosine theta, we can read straight off, is root 3 over 2, but if it's in the first quadrant, it would be positive. If theta happened to be the angle that made sine theta equal 1/2 was the obtuse angle, well, then the cosine of it would be negative. So cosine theta, I can only conclude, could be positive or negative root 3 over 2. And in fact, if you solve that equation up there, you'll get the same thing. In the next one, sine theta equals negative 1/3. So I would still draw the triangle, put in theta, and I would have my 1 and my 3 opposite divided by hypotenuse. A bit of Pythagoras makes this one root 8, which of course we would rather write as 2 root 2 because we're good people. If you can't remember that, you should come and ask me about it. But this time, sine theta is in the negative quadrant, so get rid of those. Well, let's just get rid of the whole lot and do another one then. There's my beautiful axes. Sine theta is negative 1/3. That's about there. So I could be over here. Could be over here. Well, again, the cosine would be negative if it was this angle to there, and it would be positive if it was the angle all the way around to there. So it's going to be plus or minus. And when I do cosine for this one, so cosine theta equals positive or negative, and I have adjacent divided by hypotenuse 2√2/3. I'll do a couple more because these ones are actually slightly different. The sine of theta equals 0. Can't draw a triangle for that. When is sine theta equals 0? Either here or there. What are the possible values for the cosine of theta? Well, if I was on the right-hand side, so at 0, 360, negative 360, 2 pi if I was using radians, the cosine, whenever I'm on the right-hand side, is 1. Whenever I'm over here on the left-hand side, it's negative 1, so I've got plus or minus 1. Here, when sine of theta equals negative 1, I'm down the bottom. There is only one value for the cosine of theta there. I'm on the y-axis, so the cosine of theta must equal 0. The next question, question 7, works exactly the same way. If I wanted to know the cosine of theta equals 4/5, I draw my triangle, and this time it's the adjacent side divided by the hypotenuse. That gives me 4/5. Bit of Pythagoras will tell you that one equals 3. Now, where is cosine positive? Over here. So one of them would have a positive sine value. The other one would have a negative one. So you're going to get sine theta is plus or minus 3/5. And you get the idea. Let's move on. You can finish off those ones yourself. I think you got the idea now. Without using a calculator, find sine theta if cosine theta equals 2/3. And I'm in the first quadrant. That's a bit of extra information. Now I'm not guessing, now I know. In the first quadrant, all of the functions are going to be positive, aren't they? If cosine of theta equals 2/3, adjacent divided by hypotenuse, bit of Pythagoras makes this side √5. Remember, 9 minus 4 is 5, square root √5. What would the sine of theta be? Opposite divided by hypotenuse, √5/3. And that's it. That's all you have to do. We know it's positive because it's in the first quadrant. There we go. So cosine theta is sine theta equals negative 3/5, and I am in the third quadrant. No, fourth quadrant. Look, 3 pi over 2, 1.5, lots of pi. 2 pi is a full revolution. Remember, that's pi, and this is pi over 2. So I'm in this quadrant down here. Oh, cosine's going to be positive. So I know cosine's going to be positive. Quick draw of the triangle. Opposite is 3. The hypotenuse is 5. Well, we just did this one before, didn't we? What's that going to be? It's going to be 4. Cosine of theta would actually equal positive 4/5 because in the fourth quadrant, cosine is positive. Look, it's got a positive x coordinate right there. There you go. Last couple, sine theta equals 1/3, and I am between pi over 2 and pi, which is going to place me in quadrant 2, isn't it? Pi over 2, pi. I'm in this quadrant here. Sine theta equals 1/3. So if I'm doing A, draw the triangle. 1, 3, a bit of Pythagoras. We did this one before too. That's 2√2. Remember, √8 simplifies to 2√2. Find the tan of x. So tan of x, well, this time it's x instead of theta. That was the opposite side. This is the adjacent. So tan of x in quadrant 2 is negative. So it's negative 1/2√2. Need to multiply top and bottom by √2, which is negative √2/4. And you have it. Now the book, I think, did something silly like called this √8 and had negative 1 on √8. And they multiplied by √8 over √8 and ended up with negative √8/8 or something. So I think maybe they left it like that even. It doesn't really matter. They're the same value. Negative √2 divided by 4 is, of course, much nicer, and you would have done the polite thing and done that. Let's have a go at one more of those. Let's do D. You'll probably think it's a hard one. I don't know if it is or not. Let's see. What quadrant am I in? I'm in the second quadrant again, aren't I? Between pi over 2 and pi. Okay, I'm finding tan, so it's going to be negative in radical form. That's okay. It's easy enough because all I do is draw my triangle, put in the x. Cosine is adjacent divided by hypotenuse. This is a 3. That's a 4. Bit of Pythagoras, 16 minus 9 is 7. That must be root 7. So the tan of x, opposite divided by adjacent, is root 7 over 3. But what quadrant am I in? I'm in quadrant 2, aren't I, between pi over 2 and pi. And in that quadrant, tan is negative. Alright, so the last one we have to do, question 11, find sine theta and cosine theta, given that the tan of x equals 2 over 3. And this time I am in the first quadrant. Let's just move that up even a little bit more. That will make it look even nicer. So, the tan of x equals 2 over 3. Tan is opposite divided by adjacent, so we can draw that very quickly, 2 and 3. That must place x about there. And a little reminder, in the first quadrant, oh, that is just a really badly drawn unit circle. No respect for my best friend, outrageous. But in the first quadrant, everything is positive, so I don't even need to worry about negatives for this one. That's great. Bit of Pythagoras will give me the hypotenuse. 3 squared is 9, 2 squared is 4, 9 and 4 is 13, so the hypotenuse is root 13. Remember, this is for part A, so therefore, the sine of theta is opposite divided by hypotenuse, 2 on root 13. You wouldn't be as rude as the back of your book and leave it like that. And even though I promised before that you had to come and see me, I'm going to show you how to rationalize the denominator now. I'm feeling generous. Multiply top and bottom by root 13. That, of course, is going to change the denominator to 13. And on the top, I just have 2 root 13. By the same token, cosine of theta, adjacent divided by hypotenuse, 3 over root 13. Rationalize the denominator, and I've got 3 root 13 over 13. And we are done. I'll leave you to do C for yourself. I hope that helps. Go through, watch the video, match it up with the questions, try the ones next to it, see how you go. If you're still having problems, come and see me, but that should clear up a few of them. Alright, good luck guys. Cheers.